Today you will be working through 2.2 in your homework. That's that pinky purple, not in your homework, I mean your notes packet, that pinky purple packet. And so we're going to go over slope. Now slope is a concept that I'm sure you have learned back in a previous math class. And so hopefully this is kind of review. But what we're going to do is sort of connect what we did yesterday, talking about the change and the start, or what would be considered figure 0, the initial point. We're going to make that connection to these lines in these pictures. And so for the graphs, we're going to describe how the pattern grows and then write an equation. And how many tiles are in figure 0, and then write the equation like we did yesterday. Remember, that equation looks like this: y equals change times x plus figure 0, or the number of tiles in figure 0. So if I look at this and I consider 1 to be figure 1, I can equate 1 to that 0.7. So that means if I were to make a table, 1 would have, I could do that x and y. Figure 1 would have 7 tiles. Now notice I left a space here because I want to figure out figure 0 eventually. Figure 2 is off the chart, but if I just look at the graph, now this is not figure 0, because that would be, if 1 is this point right here, and I'm skipping a line to get to the next whole number, I would skip a line to get the previous one. So figure 0 to go back would be associated with that point 3. And so then when I try to find the change, it looks like I'm adding 4 each time. And in fact, I could count that. I go up 1, 2, 3, 4 units over 1 unit, because remember, this whole thing is 1 unit. Up 4 over 1. So my pattern is increasing by 4. My figure 0 is 3. So I write this as y equals 4x plus 3. Change x plus figure 0. So let's do that same thing here. It tells me that every time I move over 1, I move up 12. Every time I move over 1, I move up 12. And at the axis, it's 9. So what that tells me again is every time I move over 1 up 12, my pattern is 12 plus 12 each time, and my figure 0 is 9, because that would be the point associated with x equaling 0. I think of input 0x, output y 9. And so 0 is associated with 9. My equation then becomes y equals change x plus figure 0. Y equals 12x plus 9. So we've got another one here. Again, I have to look at my scale. Looks like this would be 1, 2, 3. 1 is paired with, as I count up, 1, 2, 3, 4, 5. It looks like 1 is paired with 4. 0 is paired with 3. 2 is paired with 5. As I move over 1, I move up 1. So I'm increasing by 1 each time. What's my pattern? 1. What's my figure 0? Again, that's the point associated with x of 0, the point 0, 3. So my figure 0 is 3. Y equals 1x plus 3. I don't even need to write the 1 there. I could write this as y equals x plus 3 if I wanted to. So working with that change, the pattern. As I look at the next one, going on that same concept, this one is, if I move over 3, I increase by 27. If I move over 3, I increase by 27. And so if I want to set up my change, I would take that 27 and divide it by my moves of 3. What is the change for 1? I think of it as a unit. Or a unit ratio. That's equivalent to what over 1? If I move over 1, how much do I go up? So I have to think, how do I get from 3 to 1? Divide by 3. I'll divide by 3 on the top as well. 9. That makes my change 9. So that's just a different way of doing it. If I move up 27 for every 3 I move over, I want to figure out how much I'm going to move over for 1. I do 27 divided by 3, 27 over 3. So that's my slope, and in fact we call that a slope triangle. And the movement to the left or right is called delta x, or the change in x, and the movement that we move up or down is called delta y, or the change in y. That little symbol means the change in y. And so if I were to write it as a slope following the pattern that I did before, if I want to figure out how much I would move in 1, I'd write it as a division problem. I need to divide delta y by delta x. I also refer to that as the change in y divided by the change in x. Delta y over delta x. You'll hear me talk about this, or even this form, change in y over change in x. And so again, that's what my slope measures. It measures the change in y over the change in x. And in fact, we can actually write that as a little formula. We'll bring this up again later. What does it mean, the change in y? It means I'm going to be taking the y point minus another y point, the two y's that are going to be subtracted, and the x point minus the other x point. And again, we'll write that in formula form shortly, but basically it's the change in y over the change in x. All right, so moving on to the next page, we're going to look at some pictures and kind of use our slope triangle and talk about the steepness. So when I look at this, I need to picture myself climbing or descending the stairs of lines A, B, and C. So here's line A, line B, and line C. Notice line A has that sort of medium-ish slant to it. Line B has a pretty severe slant to it. And line C is a little bit flatter. So when we talk about steepest to least steep, the most severe slant, or the closer to straight up, would be the steepest. And then as it gets a little flatter, we move down to the least steep. So steepest is the closer to straight up. That's B. A is a little less straight up, and then C flattens out. But if we look at D, D goes a totally different direction. And so when we look at D, what direction is it traveling from left to right, and what number should be used for delta y to represent this direction? So let's think about what delta y was. Delta y was, or y is the change in y. So if I start from one level to move down to where the next level is, that delta y actually drops. And so if I'm talking about what number should be used for delta y, it drops 2. What direction is it traveling from left to right? I would say it's dropping from left to right. And specifically, it's dropping by 2, and that's why I write that as a -2. Now, I want to go off of how I kind of counted that. This is dropping by 2, and then I would do my delta x underneath that to find my actual slope. My slope for D, I'm on D, so I'm going to jump down to D. I drop 2, and then I move right 1, 2, 3, 4, 5 to get to the next point there. So I drop 2, move right 5, that's my slope. I want to use that same concept on A, B, and C as well. And so I'm going to do my change in y, which is the rise part. That one looks like it goes, my delta y and my delta x. So this is rise, it goes up 1, and then the next one is over 1. I could write that slope as just the whole number 1. Let's kind of go through that same concept for b. Remember, it's the rise first, so I'll count that. Here's my, I'll use one that's dotted off. This is delta y. This is, I could go down 1, 2, 3, left 1. That would be down 3, left 1, or I would call that a slope of 3 over 1, or I could even call it a whole number slope of 3. I added 2 negative moves, so let's do the same thing on this one. From move to move, I go down 1, left 2, down 1, left 2, or I call that positive 1/2. Now I can see the slopes as numbers. The B was the steepest slope, so B has a bigger number. C had the less steep slope, so it had the smallest number. D was a negative slope, so it had a negative number, or a dropping slope. And so we want to consider those things when we are working with our slope. How does the slope relate to the steepness of the line? The bigger the slope, the steeper the line. All right, so we're going to go on to our next section. We're going to do the same thing. Use a graph to answer some questions. First of all, we're going to find the slope. And again, we're going to count it. We're going to go through and use the slope, rise over run. Now, there are points indicated, so I'm going to focus on one point, and I do the change in y. So I'll pick one point in line A. I'm going to pick this point right here. The change in y, that goes up 2, oops, sorry. I started at 1, I go up 1, 2, over 1 spot. So this is 2 over 1. My slope is 2 over 1, or 2. Let's go to line B. I'm going to pick my points. Here's a point. I go up 1, 2, 3, over 1, 2. 3 and 2. My slope triangle gives me 3 over 2. I can't reduce it, so I'll leave it just like that. Now I go to line C. Here's line C. I'm going to find 2 points. So I'll start with this point here. Up 2 over 3. 2 over 3. Remember, it's rise and run. The change in the y's over the change in the x's. Delta y over delta x. Rise 2, right 3. So that slope is 2/3. Same concept on D, except for this one, it looks like I'm dropping. So when I think about my move here, it's down 1, right 1, 2, 3, 4, 5. Down 1, right 5. My slope is -1/5. And lastly, I have E. And E is a little bit hard to see. That's that straight line. So when I think about rise and run, this has no rise to get from point to point. It just has a run. I go no rise, and then I move over 1, 2, 3, 4, 5 from point to point I went on there. So this is no rise over a run of 5. I call that 0. 0 divided by anything is 0. In fact, that's something to kind of look at or discuss, and actually when we move on into our thing, we'll talk about a 0 slope versus one that we call an undefined slope or no slope. And so now they're asking us to use the answers from part A to list the lines in order from steepest to least steep. Now the bigger the number, the steeper the value. So of these, which is the biggest number? And I would say 2 is bigger than any of the other ones. So 2 is the most steep, so A is the most steep. And then 3/2 is less than 2, but more than 1 whole. And so 3/2, or line B, is the next steepest. And I'll work my way down. 2/3 is the next steepest. 1/5 is the smallest fraction. And then 0 has no slope at all. It's a flat line, so a 0 slope. We're going to again continue on working through looking at slope and looking at equations of lines and kind of using the information that we just put together. So on the graph, we're going to graph the line that matches the description. So let's think about this. This is my change, and this is my figure 0. So my change and my figure 0. Remember, figure 0 is where it starts. We can think of that as the value that's paired with 0 of an input on the graph or in my table. Figure 0 is -1, so I graph that as 0 down 1, and then this change gives me my slope, and my slope is my rise over my run, so I go up 1, 2, 3, right, 1, 2, 3, 4, 5, make another point. I go up 1, 2, 3, right, 1, 2, 3, 4, 5, make another point. I like to fill my graph. From that same start, I could also go down and left, because we saw that on the previous page. If I had a double negative, as I did in C here, down 1, left 2, I could make that a positive slope. So I can use that concept on this one as well. I could go down 3, left 5, down 3, left 5. And then I should have points that fall in a very nice line. I'll call this line A. Now I'm going to go through the same concept with B. So I have to graph a line that matches the description. This one just tells me that I have a change in y of -6 and a change in x of 4. So my delta y over my delta x is that. But it doesn't tell me anything about where this starts. And so all I can do is, it just says on the graph a line to match the description, and I have to make sure to do that. So I want to, I'm going to have to start somewhere, I guess. I'll start right up here in the corner. I'm just matching this description. It just says it has to have this slope. That slope is down 6, 1, 2, 3, 4, 5, 6, right 4, 1, 2, 3, 4. Matches the description, doesn't tell me anything else. Down 6, 1, 2, 3, 4, 5, 6, right 4, 1, 2, 3, 4. Down 1, 2, 3, 4, 5, 6, right 4, and make a point. So it matches the description. That's just where I'm starting that one. I'll call that line B. Now C, that one doesn't have y equals, but instead it has f of x equals. But we learned in last chapter that basically that just means y. And so when I think about my start and my change, where do I start? What's figure 0? How do I change? So when I think about this, where do I start? How do I change? I think of this as figure 0 is -7. That's equated with the point 0, -7. And the change is I move up 1 for every 1 I move over. So I'll start at 1, 2, 3, 4, 5, 6, 7 below the axis, that's -7, and then up 1 over 1. For every 1 I move up, I move over, up 1 over 1, and I just keep filling my graph. Keep in mind I could also go down and left, down and left, down and left. I've got enough to get a good idea of this graph, and I'll label that graph line C. And lastly, it says delta x is 0 and delta y is 3. So what I have here on this last line is the change in y is 3, the change in x is 0. Again, it doesn't tell me where to start, it just tells me the change in y is 3, the change in x is 0. So that means I'll just start anywhere. I'm going to start right here. And change in y is 3. That means I go up 3. Oops, I went the wrong way on my graph, didn't I? So my only other option is to go down 3. That's still a change in 3. I'm just doing it backwards, and that's okay. but I don't move left or right. And then I go down 3, but I don't move left or right. I go down 3, I don't move left or right. Down 3, I don't move left or right. I keep going on this. And I have just created my line for D. And now I have my 4 linear equations, and I have sketched a graph that represents each of those situations. Okay, so our next question up is, what if I knew 2 points on the line, but I couldn't find, or I didn't know anything else about the line? Well, remember I was talking earlier about our slope is our change in y over our change in x. So I could look at how did the y's change and how did the x's change, my change in y over my change in x. And I'm going to go from left to right to do that. So how did I get from 4 to 7? It looks like I went up 3. How did I go from 2 to 5? That looks like I went up 3 as well. So my change in y, 4 to 7, up 3, 2 to 5, up 3, that gives me a slope of 1. Another way that I could do that is to make a table where I have my x values and my y values. And I could just work through and try and find the pattern that I have. So if I had 2, 4, and I was looking for, trying to find how it's changing from each step, I could put in my values. I didn't really leave myself enough room. Why don't I do it here? 2, 4, sorry for that, then 3, and then 4, and then 5. And over here is 7. So how do I get to 7 here? That would be up 1, 5, up 1, 6. Find my pattern that way. That would be another way to do it. And then I could find my change. Change in y is up 1. Change in x is over 1. Up 1, over 1. All right, we're going to finish up today just with a quick summary. And then you're going to be asked to work on the homework for 2-1. And so we're going to talk about positive slope and give an example, negative slope, give an example, zero slope, and undefined. Positive slope rises from left to right. An example of positive slope would be something like 5 over 3, or negative 5 over negative 3. 2 negatives make a positive. A negative slope drops. So when I think about that slope, it would be negative 2 over 1 or 2 over negative 1. Negative slope has one negative move, not both. Zero slope. A zero slope, remember, has no rise at all. It's a flat line, zero slope, and that slope would look like 0 over a number, any number, it doesn't matter, which we call 0. And then no slope undefined, that's one that's straight up and down, and we graphed that earlier, straight up and down line here, that was graph D. Notice that it was a number over 0, that my change in x was 0, and so when we do that, we would do any number over 0. And I just randomly chose the numbers that I used here, but remember, a positive slope has either 2 positive moves or 2 negative moves. A negative slope has one negative move, either on the top or on the bottom. Zero slope has no change in y, and an undefined slope has no change in x. So your job is to do the next section in your homework packet. And I'm just pulling out a copy of that so we can take a look at it. You have 2, 2, and there are a lot of problems in there. So 2, 2. I would like you to do problems 1 through 13, and then we'll go through those together before we start our next work. So that's problems 1 through 13 is your homework from section 2.2. So again, 2.2 in the homework packet, 1 through 13. And I will see you in class tomorrow.